The center of mass of the system does not depends on frame of reference. And second point is center of mass of system depends on mass distribution and location where where the mass of object is located. Third, according to center of mass, the algebraic sum of moments, linear moments, mi xi bar about center of mass is 0. And fourth one is center of mass depends on shape and size of the object. Fifth point is location of center of mass either may be inside or outside the object. And the last point is at the position of COM may or may not exist a mass of this particular system. So these are the 6 important characters that we need to be take care over the center of mass of system. And very important thing note, that is the motion of center of mass does not influenced by the internal forces. Whatever the internal forces does not influence the motion of the center of mass. Only external forces causes for motion of center of mass. Next one. In calculation of center of mass or in consideration of center of mass, we have different type of approaches. I sometimes we have to use integration method, and sometimes we have to use normal method of calculation of center of mass. Anyway, in the next complete expansion for the each and every point, let me explain. The first one, what is the first point we wrote here? Center of mass of system does not depend on frame of reference. That means if you try to consider a rectangular plate, for the rectangular plate which having the uniform mass distribution, definitely center of mass is exists at the geometrical center. Now, this position of the center of mass does not change depending on the viewer or depending on the frame of reference. The first point. Second point is the COM depends on the mass distribution and where it is located. In the given coordinate system, suppose these are all the massive particles. Okay, if the massive particles are interchanged at different positions again, the final location of center of mass also changes. Therefore, it depends on distribution of mass and also depends on the location. If the center of mass is where, if the heavier masses are very near to origin, then center of mass is in the surroundings of origin. That's it. Next one is the algebraic sum of moments are going to be 0. I'm taking in the form of vector. Okay, let me explain. For example, let us try to consider there is something like a lamina like this, and this is the location of the center of mass. Now, I am considering the different points which are at R1, R2, R3 left side, R1, R2, R3 right side. So whatever the masses at these locations, the same masses are there. When you take left hand side as negative and right hand side as positive, with respect to center of mass, algebraic sum of linear moments will be again 0. That means left hand side sum is equal to right hand side sum. So when you take out total value, that entire RHS will come to the LHS part, will give you a subtraction overally, will get answer as 0. Therefore, algebraic sum of moments about center of mass is 0 here. This is the mathematical explanation. Okay, please take care. After completion of rotatory motion torque concept, you can elaborately learn about what is meant by here moment. Okay, center of mass depends on shape and as well as size. If the object size is very very less, then only center of mass is exactly geometrical center. If the object size is very very large, at such a condition, the center of mass slightly deviates from its actual expected one because of the new coordinate called as center of gravity. Different shapes contains a different type of position of center of mass. Even though mass of the entire system is same. Example, let us consider a square. Location of center of mass is here. You recast this one into a solid sphere. Again, center of mass location will be different. So therefore, depends on geometrical shape, depending on the size of the object, the position of center of mass going to be changes here. Next one is location of center of mass may be sometimes inside, sometimes outside of the system. Let me explain with an example. Inside example, there's a tenoid ring. Tenoid ring already we know. Center of mass exists at exact this particular point. Okay, so second, let us consider something like a V-shape metal rod. V-shape metal rod. Center of mass is located here, and take the square lamina. You have center of mass here. So in the square lamina, we have center of mass inside the or inside the body. Here, tenoid ring and V-shaped structure. We have center of mass at outside the body. So center of mass location is a little bit different concept. Next, at the position of center of mass may or may not have mass of object. And look at here, previous example. Here the location of center of mass, there is no mass. That means there is no constraint, fixed constraint. There should be some mass. Absolutely wrong. There may or may not be exist center of mass. Okay. So these are the important concepts what we have to be explored about this particular center.